Alright, so I'm going to leave this up to you to read, but I am going to read some of these things for you. So this is just saying that how you work a proof. You pick a side, you pick that side, and then you want to go to the other side. So here's some helpful techniques. When you're trying to pick the side, it is usually easiest to start with the more complicated side because it's easier to take something complicated and make it less complicated. So you want to start with the more complicated side. That is almost always a true statement. The second hint is look for algebraic things to do. So if there are two terms and you only want one, you can add the fractions, factor something out. This is that GCF that we were talking about in the last video. So like, I don't know, I'll do 2ab plus 7a. So you could take out the a's from both and you'd be left with 2b plus 7. That's what greatest common factor is. Adding fractions, what do you have to do in order to add fractions? You have to have common denominators. Must have common denominators. Alright, going on. Multiply by a clever form of 1. That's usually to get the common denominator. Also, though, here's a word you've probably never seen. Multiply a numerator or denominator by its conjugate. So, conjugate, this is going to take some space for me to write. Oops. But conjugate is part of the difference of squares. So the difference of squares that I was talking about. Let's take 1 minus sine squared. Now, if you were to factor that, so factor means to pull it apart into two groups. That would be 1 plus sine x and 1 minus sine x. These guys are each other's conjugates. I really consider conjugates like the other half of a difference of squares. So, for instance, so hopefully you're writing this down somewhere. What is the conjugate of cosecant x minus 1? Well, the conjugate would be the other difference of squares. So since this is the minus 1, you'd have to have the plus 1. So this is the answer to the question I asked, cosecant x plus 1. Now let me ask you a second question. What does this equal? Well, we know that when it would multiply, it would make cosecant squared minus 1. Well, that's good and true, but more than likely, I'm going to ask you to go further. What else does it equal? So this is when you can say, well, let's go look at Pythagorean theorem, and we would find that it equals cotangent squared. So, I mean, this is me. These aren't real questions or anything like that, but that's why we use conjugates, is somehow down the line, it's probably going to lead you to Pythagorean theorem. All right, let's keep going. Do any obvious algebra or arithmetic such as distributing, squaring, or multiplying? Honestly, I see more algebra mistakes than trig mistakes. You got to know basic algebra, how you can subtract numbers, how they are associative or not associative, all those things. And keep looking to make sure you're headed in the right direction. If you get stuck, maybe you're there. Maybe you finished and you just don't know it. So make sure you look back and see if you're there. I skipped these. Search for familiar trigonometric expressions such as 1 minus cosine squared. We should all say that that's familiar to us as sine squared. This is 1. Sine over cosine is tangent. So these should be familiar to you. Even if you can't say what they are right now, you should at least be able to know hey, maybe if I look at my formula chart, I see them. Okay? If there are squares of functions, think Pythagorean theorem. Also, if there's a 1, think Pythagorean theorem. And then reduce the number of different functions, transforming them to the ones you want. That can be really ambiguous, so let's just start some examples. Oh, that's all that I have on here for some reason. Well, that's not right. Let me pause 1 second. Alright, so I had the intention of doing some homework problems with you, or some example problems, but I can't find any, so let's just go on to the homework. So I'm looking at the homework 5.2. So if you need to pause this and come back to it so you can print the homework, that's fine, but I'm just going to go to a blank page and I'll just rewrite these. So I like number 3. Let's do number 3 together. So when you're looking at those two sides, well, let me write out the whole problem since it's not on here. I don't like green. I get cosecant squared x minus cosine squared x times, I like to write that little times symbol, cosecant squared x equals 1. So one of those helpful hints stated to start with the more complicated side. When you're looking at the two options, 1 is obviously about as uncomplicated as it gets. So this is the side that you're going to want to start with. So let me rewrite that. I really do want to see your first step is just writing the side that you're picking. So you should be writing this down with me. All right. Now, if your preference is to change to sines and cosines, it's good. It really is. But you're going to find that that is not as easy as what I'm about to do. When I read this problem, even if you are reading it to yourself, you should hear, your brain speaks to you, and you should hear cosecant being read 2 times. Being read for this group, being read for this group. So you do have a greatest common factor of cosecant squared. Okay, so let's GCF that out. Cosecant squared. Now, we've done a problem similar to this. You have to kind of imagine distributing. When you would multiply cosecant squared times what, how would you get cosecant squared? Well, you still have to multiply something. It's non-optional. You have to multiply something. So what you'd have to multiply to get itself is 1. Then I have this minus sign. Don't forget this minus sign. It's very important. And now multiply times what group here to get cosine squared, cosecant squared. Well, I already have the cosecant squared. I pulled it out. So what I'm missing is the cosine squared. Close that parenthesis. So I would love it if you were at the point where you were thinking, well, inside of this parentheses, this group has 1 minus cosine squared, and that's starting to sound really familiar. So what does this sound like? Sounds like Pythagorean theorem to me. So it becomes sine squared. I still have cosecant squared. They multiply to 1. Okay? All right, let's do another problem. So let's look at your homework. Let's do number, I don't think we're there yet. 8. I keep picking these ones. Okay, I'm not going to write the side of 1, so I'm just going to write the side I'm starting with. Sine x over cosecant x. Oops. Plus cosine x over secant x equals 1. I'm picking the side to start with, obviously. Now, this problem can be a real, I don't know how to say it besides booger. It's not fun until you really, really understand. So I'm going to try really hard to explain it, and hopefully that makes sense to you. Now, what you're probably thinking is fraction plus fraction, let's do common denominator. So let's pretend like you're not listening to me and I'm saying that's probably not a good idea. Let's pretend like we're going to do common denominator. So I need cosecant, I need secant, and I need secant. Now, I've just made something that was bad even worse. Because now nothing cancels on top. Usually when you do common denominator, it makes something better somewhere. I've got sines, I've got secants, I've got cosecants. This is getting to the point where, even though I know you probably don't like any of them, this is bad because I don't recognize any of this stuff. Even if you try to continue, you would say, well, secant is 1 over cosine. It's just really, really bad. So I'm going to take away all of this stuff because once you get to a place where you're just thinking, I think no, then try again. Okay? So back to the original problem. So you can pause it and erase. Here's the thing. Look at this group and look at this group. What do you notice about sine that's on top and cosecant that's on bottom? Hopefully you recognize the fact that they are reciprocals. Well, the fact that they are reciprocal says that if cosecant is currently on bottom, I could put him on top by writing it as a sine instead. And I've already got this sine on top, so when I put this sine on top, it becomes sine squared. Same idea here. This secant I could rewrite as cosine on top, which makes it cosine squared, which is 1. Really and truly, these proofs are not going to be insane. I mean, yes, there's going to be 1 or 2 of them that are bad, but that last thing that I had wrote before this nice pretty one looked bad to me. It was sines with secants, with cosecants, all in fractions. That's not good. They're probably not going to be that hard. So skip the problem if you need to and come back to it. And if you still can't get it, then ask me. Just make sure you ask me before the quizzes. All right, let's do number 6. I guess we're ready. Now, number 6 is kind of questionable which side is harder. But in my opinion, raising something to the 4th power is harder. You could argue that. It's not, but I think it is. If you think the other side is harder, you can by all means start on the other side and get there. Okay? All right. Now, what we need to do for this problem is we need to remember difference of squares. Again, I'm going to come over here to the side, and I'm going to ask you, how do you factor x squared minus 16? Well, x plus 4, x minus 4. How do you factor x squared minus 25? X plus 5, x minus 5. Well, that's good and fine. I don't have squares though, I have fourths. So, how do you factor x to the 4th minus y to the 4th? Well, the thing about difference of squares is that you're allowed to do it because you can take the square root, you can take the square root. So when you took square root of x squared, it became x. When you took square root of 16, it became 4. Separate with plus, separate with minus. Well, can you take the square root of x to the fourth? Yeah, it's x squared. Can you take the square root of y to the fourth? Yeah, it's y squared. Separate with a plus, separate with a minus. Well, now this actually becomes interesting because I'm basically solving this trig problem, but is this difference of squares? Well, it's squares, but is it difference of squares? No, it's not. This guy, I can't go any further than. But is this difference of squares? Yeah, it is. You could do x plus y, x minus y. So, in algebra, this is how you would factor that. All right, let's go on now. So go back to the trig, and I want you to try and factor x cosine to the fourth x minus sine to the fourth x. Go ahead and try to factor cosine to the fourth minus sine to the fourth. So I get cosine squared plus sine squared. It doesn't matter if you separate with the plus first or second. Cosine squared minus sine squared. All right. Now, let me ask you, what is this? I would like for you to pause this till you get the answer. Because if you can't give me this answer, you're not listening hard enough. Cosine squared plus sine squared is 1. When something equals 1 and then you have times, do you really need to write that? Sure don't. So I'm just going to erase it. And I'll take off these parentheses. If I'm not going to multiply anything, I don't really need them. All right. Now, let's see where I am. Let's see where I need to be. This is where I am. This is where I need to be. I see a sine squared. I see a sine squared. I see a cosine squared. I don't want a cosine squared. What can I write cosine squared instead of that? Well, let's do some more Pythagorean theorem. I can write 1 minus sine squared instead. Then I still have that other minus sine squared. So where do I end? Well, I end with negative 2 sine squared. I don't know why I changed to y's. I'm really sorry. That's really crazy of me. X, 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 X. Alright. I should stop this video. I'm tired.